In this video, we're going to learn about the binomial distribution. In our last video, we learned how to create a probability distribution for discrete values. And here we're going to just look at a particular distribution. So it has certain characteristics. The binomial distribution must consist of an experiment of a fixed number of identical and independent trials. So the trials must be independent or it is not going to be a binomial distribution, and there can only be two possible outcomes, success and failure. Now be careful with this one because yes, it's two outcomes, but if say I'm rolling a die and I say I win if I roll a 1 and I lose if I roll a 2, 3, 4, 5, or 6, that's two outcomes, success and failure. So even though when I roll a die there are 6 outcomes, there's really just two outcomes, success and failure. The values that we're going to need to know would be P, which is the probability of success. So if I'm looking at this made-up scenario, P would be 1/6 because that is the probability of rolling a 1. The probability of failure is simply found by taking 1 minus P. And that's again because we know that all of the sums of the probabilities must add up to 1. So if P is 1/6 and there's really only two outcomes, then 1 minus 1/6 is 5/6, which we can see visually here. And then the number of trials. So the number of trials would be, say I'm playing this game 20 times. Well, that would be my n value, 20 times. The random variable, which is denoted by x, would represent the number of successes that I'm looking to find the probability for in n trials. So let's say I said I'm going to play 20 times and I want to know the probability that I win 5 times. Well, then that would make x 5. So I would set it up like this. The probability that x is equal to 5 is equal to 20 choose 5, and then the probability, which is 1/6, to the 5th, and then 1 minus 1/6, which is 5/6, to the n minus x. So really, if x is 5 times and I'm doing a total of 20 times, that's 15. 20 minus 5, 15. So this time, let's look at a question and let's actually find the solution. So on the last one, we really were just practicing which values are which. So if I'm trying to find the probability of getting exactly 6 heads in 10 tosses of a coin. So first of all, is it binomial? Does the experiment consist of a fixed number of n identical and independent trials? Yes. 10 trials, the outcome of one event does not affect the outcome of another event, so they are independent and of course identical because each time I'm just flipping a coin. And there's only two possible outcomes, success, which is heads, and failure, which is tails, and of course n would be the 10 tosses. So let's go ahead and find the values and then set up our equation. The probability of success, we said, was 50% because half the time I'm going to get heads, which means the probability of failure is 1 minus 0.05, 1 minus 0.5, which is 0.5 or 1/2. We have 10 trials, and the question asks for exactly 6. So note the key word here, exactly, because we're going to look at a cumulative distribution in a little bit. So x is equal to 6, and we're using just the binomial distribution, not a cumulative distribution. So here's how we would set it up. We have 10 choose 6, and then 0.5 to the 6th, and then 1 minus 0.5, which you can just write as 0.5. And then again to the 10 minus 6, which you can just write as 4. You don't need to write the 10 minus 6, but that's how we found it. So what's this going to look like? Well, we know that 10 choose 6 is 10 factorial over 6 factorial and 10 minus 6 factorial, which is where that 4 came from. Now, here's my advice to you. it's okay to go ahead and calculate what 10 factorial over 6 factorial 4 factorial is. Or what I do is once I get to this point, just use your calculator to calculate the entire expression, because what I find students do quite often is they'll find this value and round it, and they'll find this value and round it, and then this value is not as precise as it should be. So once you get to this point, it's okay to just calculate the result. So we get about 0.2051. Let's take a look now at how we can use Excel to do this calculation for us. So we've already done this by hand, and we found 0.2051. To do this in Excel, I'm going to show you two different ways. The first is just choose a cell, start entering binom dist, and again, we're still going to need to be smarter than Excel. So we still need to know that this is a binomial distribution because we have independent trials with two outcomes, success and failure. We also need to know what is P, what is N, and what is X. Now, lucky for us, we already know all of those things because we've already done this question. So all I need to do then is type in binom dist and then take the number of successes. The number of successes again was 6, that's our random variable. The number of trials, which is N, and then probability of success, which is P, 0.5. For cumulative, it's going to be 0. And we'll talk more about cumulative in a little bit, but the key here is anytime it says exact, cumulative is going to be 0 or false. So here's my solution, 0.205078, which is about 0.2051, which is what I found by hand. Now that's great, and it works every time. So you will do something like this when you're working on your project in Excel. Now, as you're working through your certifications, you might want to take it a little bit easier. So instead of having to type out binom dist each time, set up your spreadsheet like this. So if I take X, which again is the probability of success, N, which is the number of trials, and P, and then I create a cell like this, binom dist, and I know that X is the number of successes, N is the number of trials, P is the probability of success, and 0, because it's always going to be 0 right now whenever it says exactly 6 or exactly some number. And notice I have the correct solution, and the advantage to this way is on my next question, instead of having to type everything out again, I just change the values for X, N, and P. So let's take a look at another question. So our next question is dealing with a quality control expert at a large factory. He's taking a random sample of 15 batteries. What's the probability that exactly 2 are defective? So again, before I get started, I have to ask myself, is this a binomial distribution? All of the batteries that I'm choosing, each trial is independent because whether or not one battery is defective does not affect whether another battery is defective, considering we're taking a random sample. And there are 2 outcomes, success and failure. So success in this case, which seems counterintuitive, but success in this case is going to be a battery that is defective, because at the end of the question it says the probability that exactly 2 are defective. So that's what we're trying to find, is defective batteries. So why would I want to create my spreadsheet like I have? Well, in this case, we're saying 2 out of 15 batteries with a probability of 10% or 0.1. And so just like that, I have the solution without having to do any more work, as long as I know X, N, and P. Now again, could I have done it this way? Of course. What's the the number of successes? 2, exactly 2. The number of trials, 15 batteries. The probability of success is 0.1. Cumulative is 0. And again, I get the same result, but this way is easier because I get to keep reusing the same solution space. Now, I've used the terminology of cumulative several times already in this video, and I haven't explained it to you, but now we're going to talk about what that means. So far, we have looked at the probability of something happening an exact number of times, exactly 2 out of 15 or exactly 6 out of 10. Now we're going to take a look at what happens when we want a cumulative, meaning some number or more or some number or less. So for instance, if I want the probability of flipping 7 or more heads in 10 flips of a coin. So if I were doing this not using technology and just finding it by hand, I could find 7 or more by saying, okay, 7, exactly 8, exactly 9, and exactly 10. Now that's not horrible, except that we know the probability that x is equal to 7 requires me to take 10 choose 7, and then 0.5 to the 7 and 0.5 to the 3. And then 10 choose, probability that x is 8 is 10 choose 8, 0.5 to the 8, 0.5 to the 10 minus 8, which is 2. And I would take that value and I'd add it, and then I would add it to the probability that x equals 9 and the probability that x equals 10. Now, it wouldn't be horrible to do that. It would take a little bit of time, but it's only 4 outcomes. Or I could take the probability that x is greater than or equal to 7 is equal to the probability, or 1 minus the probability that x is less than or equal to 6. So 0, 1, 2, 3, 4, 5, 6. Now you might be saying, well, that would be really dumb because that's more work. And you're right, except this is the method that Excel is going to use. So we need to understand what this means. So again, let's talk about the fact that even though if I started going through this question, I would say x is 7, n is 10, p is 0.5. When I use Excel, I am not going to use x is 7. And again, here's why. When Excel calculates a cumulative probability, it's calculating from the number that you give to the left. So if I use x is 7, it's going to say 7, 6, 5, 4, 3, 2, 1, 0. And I need it to just say 6, 5, 4, 3, 2, 1, 0. So I have to change that value to 6. So let's take a look using Excel, and we can see what the differences are. So let's take a look now at how we can utilize Excel. Now, I am a big advocate of A, understanding how everything works, but B, not wasting time if we don't need to. So we've already talked about how to use spaces in Excel for X, N, and P. And now I want to show you how to be a little bit next level in Excel. So we have already talked about this exactly X. And we said it's binom dist, and it's the number of successes, the number of trials, and the probability of success, and then 0 for cumulative. But now we're going to get into less than, at most, at least, and more than. So looking at this question, we want the probability of flipping 7 heads or more. Now, we talked about the fact that we could then take the probability of exactly 7, exactly 8, exactly 9, exactly 10, and add those together. And so that's what I've done here, so you can see the correct solution is 0.1719. But let's talk about how to use Excel to find the solution. Now, I want to preface what I'm saying with the fact that when you're doing this for your, say, forum posts, or when you're doing this for a project, you need to know how to plug it in and not use these spaces, because I will be clicking on the link to look at how you did this, not you showing me my spreadsheet back at me. Okay, so let's take a look first at how I would do this without using my special spaces, and then we'll talk about how to set these up. So again, for a forum, for a project, you're going to need to know that if I'm calculating the area to the left, I'm going to use binom dist with true. Now, the area to the left and the area to the right, it's important to understand that when I start this, first of all, Excel always goes to the left. So here I'm trying to find 7 or more, so I'm going to use 1 minus. So we've already talked about that. If I do 1 minus, whoops, sorry, I was in the middle of typing and then I tried to click away. So I'm going to do 1 minus binom dist. And again, I need to be smart enough to know that the number of successes will in fact be 6. 6 successes, and I can do 7 minus 1, which will make sense when I show you what I do over here. And then the number of trials is 10, and the probability is 0.5, and cumulative is 1. So by doing it this way, and I'm just going to change this back to 6 so that it makes sense. I'm saying let's find 6, 5, 4, 3, 2, 1, 0 and subtract it from 1, and that's going to give me 7, 8, 9, and 10. So notice this is the correct solution. It matches exactly what I found here, 0.1719 essentially. Now, that's exactly what I would do for a forum post. That's exactly what I would do for a project. If I'm working on my certifications and I just want to be kind of lazy, I'm going to set up this amazing spreadsheet to do the work for me. So we already talked about how to set up exactly B2, B3, B4, and 0. Now let's take a look at less than x. So less than x is not including the number that we're given. So notice I'm going to take B2, which is the number of successes, minus 1, and then B3, B4, and then 1 for cumulative. So all of these are going to be cumulative. At most x, again, is going to be exactly the number that we're given, and then to the left, because at most would be anything including that value and then to the left. At least includes the value, so if I said at least some number, that's going to be like this question, 7 or more. So that would be at least 7. So notice what I'm going to have to do. I'm going to take that number minus 1 like I did here. So 6 and then 10 and then 0.5 and 1. And then for more than is simply going to be greater than that number. So let's take a look at how that's going to work. Number of successes, 7. Number of trials, 10. Probability of success, 0.5. Now, which one's the one that I want? I want at least, because at least is 7 or more. So that's the problem I see often, is people will try this and then use 7 instead of 6, and then they get 0.054, which is more than x. So it's more than 7. So again, that's why we need to make sure that we are smarter than Excel to be able to calculate the correct value. Here's another question for us to try, and as you can see, I've already filled in the 2 for more than 2 girls, the 6 for the fact that the family has 6 children, and 0.5 for the fact that it's 50-50 whether you'll have a boy or a girl. So I have a lot of students who do this, and then they come up with these 5 solutions, but they can't tell me what they mean. So let's talk about what they mean and which one of these is the correct solution. So if you'll recall, this guy is exactly 2. That's not the one that we want, because here we're talking about a cumulative distribution, and so it's exactly 2, and that's not what I need. This one says less than 2, so this is less than 2, not including 2, so this would be 0 or 1. At most 2 would be less than or equal to 2. So that's 0, 1, or 2. At least 2 would be greater than or equal to 2, because that would be 2, 3, 4, 5, 6. And more than 2 would be greater than 2, which would be 3, 4, 5, 6. So based on this question, which one do we want? It says the probability that a family with 6 children has more than 2 girls. More than 2 means 3, 4, 5, or 6. More than 2. So our solution is there is a 65.63% chance that the family with 6 children has more than 2 girls. This one is for you to try on your own, so press pause, try this question, then press play to see how you did. So 20% of the programs sold at home games of a professional sports team contain a special discount coupon. If all 8 friends in your group bought programs at one game, so that's N is 8, and probability of success is 20%. What is the probability that at least half of your friends, so 4 or more, at least 4. Now again, the way I have it set up makes it very easy to see that at least 4 would be 0.056, so about 5.6%. But again, if I'm doing this for, say, a forum post or for my project, I'm going to want to see equals binom dist, and this is at least half. So again, I'm going to have to take 1 minus, and then instead of 4, I'm going to say 3, comma, 8, comma, 0.2, comma, 1. So I need to be smart enough to know how to use the function and not just plug in 4, 8, and 0.2. So again, if I'm looking at least half, then that's probability that x is greater than or equal to 4, which means I want 1 minus the probability that x is less than or equal to 3. Up next, we have another distribution known as the Poisson distribution.